Let us look at dice problems. You might have used a die or a pair of dice in a board game. A die, which is singular for dice, is a cube-shaped object with 6 faces. Each face has dots on it. The dots represent a number between 1 to 6. So, if there are 2 dots on a face, that face would read a value of 2. When you throw a die, the face showing up carries the value. For example, in the given diagram, the red die is showing 6, whereas the wood-colored die is showing 1. Let us look at a problem. You throw a die. What is the probability of getting a number less than or equal to 4? Now the values that could come up are 1, 2, 3, 4, 5 or 6, since there are 6 faces of a die. So the total number of outcomes would be 6. Now to get a value less than or equal to 4, my favorable outcomes would be 1, 2, 3 and 4. In other words, I would have 4 favorable outcomes. Hence the probability of getting a number less than or equal to 4 would be number of favorable outcomes divided by total number of outcomes, which is equal to 4 by 6 or 2 by 3.
That looks easy. The problems in my book were harder.
Wow, Ayush, you are getting the hang of probability. Let us try another problem, a tougher one this time. 2 dice, one blue and one red, are thrown at the same time. What is the probability that the sum of the two numbers appearing on the dice is 7? Now let us look at the possible outcomes of blue die. There would be 6 outcomes, 1, 2, 3, 4, 5, 6. Similarly, the possible outcomes on red die would be 1, 2, 3, 4, 5, 6. But we have to work on the sum of the numbers appearing. Can you think of a way to represent all the numbers and their sums at the same time? We could draw a table. In rows, let us write the possible outcomes from red die. And in columns, let us write the possible outcomes from blue die. Now let us find the sum of the numbers and fill up the table. So with 1 on blue die and 1 on red die, the sum that I would have is 1 plus 1. Similarly, when there is 2 on blue die and 1 on red die, the sum would be 1 plus 2. And let us carry on. I get 1 plus 3, 1 plus 4, 1 plus 5 and 1 plus 6. And our table is complete. Can you count the total number of outcomes? Let me remind you that we only have to count the sums this time. We don't have to count the individual outcomes of the dice. So there are a total 36 number of outcomes.
We filled the table in rows. Can I fill it column wise?
Yes, absolutely. Now let us circle all the 7s appearing in our table. All the 7s are appearing on the diagonal. Let us count. There are 6 number of favorable outcomes. Now my number of favorable outcomes is 6 and my total number of outcomes is 36. So my probability of getting a sum 7 is 6 by 36 or 1 by 6. Let us look at another problem. A die's faces show the numbers 1, 1, 2, 3, 3 and 5. Wow, this is a different kind of a die. Instead of the usual 1, 2, 3, 4, 5, 6, we have different numbers showing up on the faces. Now, this die is thrown twice and the total score in 2 throws is noted. What is the probability that the total score is at most 6?
A die is thrown twice. Is that the same as throwing 2 dice at once?
Good going, Ayush. Yes, both events would fetch the same result. Now let us look at the possible outcomes of first throw. They would be 1, 1, 2, 3, 3 or 5. let us denote them in blue color. Similarly, possible outcomes of second row would again be 1, 1, 2, 3, 3, 5. Let us denote them in red color. Similar to the previous problem, we have to work on the total score from the two throws. What would be the best way to represent all the numbers and the sums? Recall that we used a table in the previous problem. So, let us draw a table once again. In the columns, let us represent the outcomes from first row. And in the rows, let us represent outcomes from the second row. Let us find the sums now. Let us work row-wise. You could also work column-wise. I am going to fixate possible outcome from second row at 1 and work on the sums. Similarly, the second row and the third and the fourth and the fifth and the sixth. And our table is complete. Can you count the total number of outcomes? Yes, it is 36 because there are 6 faces on one dice and 6 faces on the other dice. So I can actually do 6 multiplied by 6 equals 36. Now let us circle all the numbers which are less than or equal to 6. Wow, there are a lot of numbers. Can you count these? My number of favorable outcomes are 29. It is cumbersome to count all the circles. The other way to count favorable outcomes is to count the non-circle items and subtract that from 36. We would still get the answer as 29. Now, my number of favorable outcomes is 29 and my total number of outcomes is 36. So, my probability of total score being at most 6 is 29 divided by 36.
Phew, that was hard work. But now I know what to do when the words probability and dice appear together.
You would get faster with practice. Why don't you try a problem on your own? Ayush rolls a pair of dice. What is the probability of the sum of the numbers appearing on the dice is 13?
13. The largest sum possible would be 6 plus 6 equals 12. There is no favorable outcome. How do I find the probability?
Well done, Ayush. The probability would be 0 as the numerator would be 0 here. Go ahead and try other problems from your textbook. If you need more help, check out the question bank.
Oh yes, now I know I can ask you if I'm stuck. Thanks, Miss Owl.